In this theory paper from the Waec 2020 Waec exam, here is a question on construction in which we are asked to use a ruler and a pair of compasses only to construct, in the first case, a triangle ABC with line AB to be 7.5 centimeters, line AC to be 13.5 centimeters, and angle ABC to be 120 degrees. And then we should find the locus L1 of point which is equidistant from A and B, and in the same vein the locus L2 of point equidistant from B and C, and then using N, which happens to be the point of intersection of line L1 and L2 as a center, we are to draw a circle to pass through the point A, B, and C. So we are going to be taking our ruler and compasses that they just asked us to use, and we are going to be constructing this triangle and finding the solution as requested. But before we do that, I just want to run through a rough of what we're going to do so that we can have at the back of our mind, this is what the diagram is going to look like. Then we can appropriately plan and also section our construction paper as appropriate. So in this case, we are told that line AB is 7.5, line AC is 13.5, and angle ABC is 120 degrees. As a rule of thumb, it's ideal that we start with the angle so that we can get the inclination of the side of the triangle as appropriate. So here that we are told that ABC is 120 degrees, that means it is at point B that 120 degrees is going to reflect. So if we have a straight line like this, we can say we want to locate point B. So this will be point B, and it is on point B that we can mark off 120 degrees. So from B, we want to mark off 120 degrees to go to line A. Okay, something like this. But for me, I will just note that here this is going to be 120 degrees. Okay, and then from B to A, that will be 7.5 centimeters. So this is going to be 7.5 centimeters. Okay, and then the other thing we are told to do is to find AC is 13.5 centimeters. AC, so from A to C, and you know C is also going to be on inclination of the line from B. So I can just take another line from A going to, this will be quite longer than 7.5, almost twice the length. So I can stop here to say this is now point C, that is 13.5 centimeters from A. Okay, so this is the triangle that we're asked to construct. It's going to look something like this, and then we have to find the locus L1 of point equidistant from A and B. The locus of point equidistant from A and B is going to be the perpendicular bisector of this line AB. So we are going to have something like this. This is just a rough, okay? So no problem. We are just trying to look at that rough. Okay? We are going to get that. So this will be the line L1. This will be line L1. And in the same vein, we have to look at another perpendicular bisector of B and C. So that will also be something like this, because it will divide the line BC into two equal parts. That is what will define the locus of point equidistant from B and C. So this will be the line L2. This will be line L2. And then the point of intersection, like we are told there, N is the point of intersection. This is N. Then we have to draw a circle to pass through the point A, B, and C. So that means that from N to any of these points, any of these vertex of the triangle, it's going to be the radius of that circle we have to draw. So the circle will now look something like this. N as the center, then from here, you may have something like this. Okay, and then the circle will just continue and go all around like this. So this is what our diagram is going to look like. Alternatively, you could have said maybe this is B, A could have been inclined to this side, and then in that case C will come to the left, but you will still get almost the same. You get the same thing. It's just that now your angle will be flipped to the other side. So this is what we are going to construct, and we are going to take out our construction sheet and use just ruler and compasses to define all of this that we are looking at in this diagram. Now, since we understand what we really want to do, we can go ahead to carry out our construction as appropriate. And the first thing that we want to do is that we we want to draw the straight line. So a straight line on the ruler, that's going to be the general reference, and I want to identify the point B. Okay, so I'll just take a particular point, let's say here. That will be my point B. Okay, so I can just label that appropriately and say everything will actually now emanate from that point B, since I've identified that as the point of reference that will be appropriate for me to use. Now, to construct angle 120 degrees at point B, what we do is we bring the compasses to that particular point, okay, and then take an arbitrary radius, not too large. So we just want to take this particular arc, which is going to be angle on a straight line, and that is 180 degrees. But now, maintaining the same radius, okay, we'll still maintain that same radius. We can take the compasses to one end of the arc that was just drawn. So that's what we're doing here. And then we can mark off the 180 degrees that was just drawn. And here, what we are doing is that this particular arc is marking off 60 degrees to this left, okay, and then to the right is 120 degrees, because that arc that we used to mark, if we mark another one here, we are dividing that particular straight line angle into 3 equal parts. Now, one part is taken out. One part of 3 is actually 60 out of 180. So the remaining here is 120. So there we have our 120 degrees. Okay, so that is done. We want to mark off the line AB, and AB we are told should be 7.5 centimeters. So to do that, we just need to bring in the ruler and then mark off 7.5 centimeters on the ruler. So if we go to the starting point of the ruler and we extend that to 7.5, just try as much as possible to be accurate. So this is 7.5. That is what we're going to use to mark off an arc from B, but it will be linking this particular arc that we have drawn. So if you want to take it, it should go from here to here. So we can mark off our point on this arc. Okay, so once we've done that, we'll now need to bring in our ruler to appropriately join this particular point B, but it needs to pass through the arc that will mark off as 120 degrees. Okay, and then we can bring in, so then we can mark this off on our construction sheet, and that is how we will be able to actually get our point A as requested. So here, this will be point A. Okay, that's point A, and you can see we mark up the 120 degrees, and then we look up with the marked 7.5 centimeters and draw a straight line passing through point B to point A, and then we can label this appropriately that this is 7.5 centimeters, and then we already have our 120 degrees. This is 120 degrees. Okay, then we're also told that the length of side AC is 13.5 centimeters, and in the same way that we just mark off A, we can actually go to the ruler and use the compasses to mark off 13.5 centimeters. That is almost extending to the full length of my compasses, but no problem, you'll be able to do that quite easily. And then I will now mark off from point A, because we are going to see from A, and this is what I need to do. So just maintaining that my point of compasses on the right position, I will need to go to point the line from B, this straight line. Okay, and then I will need to mark off that particular arc, and the intercept between that arc and this line is going to give 13.5 centimeters that was measured on the ruler to give us point C. So here you can just mark off that. You can see, and once that is done, you can just appropriately label again after we just join the 2 points A to C. So that's what we are left to do now. I want to join point A to point C. So just bring in your ruler and join those 2 points. And I want to use blue ink again. So yeah, I can just draw a straight line. Alright. So just like that, our triangle is done and dusted, and I can just mark off the point C. So this is point C. Alright. And it is 13.5 centimeters from A. So I can just append that as appropriate. This is 13.5 centimeters. Then we are now asked to find the locus of points that is equidistant from A and B. The locus of points equidistant from A and B is going to be the perpendicular bisector of the line AB, okay, such that at any point on that particular line, the distance from A to the line and the distance from B to the line, they are going to be equal. So for us to now bisect the line AB, we just take a particular radius, okay, but we need to be consistent with that radius. So just take a particular radius and we are going to use it to mark off. I think I'm okay with the ruler for now. So let's say we mark off this particular point here, and in the same vein we also mark it off here. And then we're going to use the same radius and also take the compass to point B, and then at point B we cross the other arc that we just drew, okay, and then we also go to the one on top and we also mark off that. So what we've just done is that we've been able to successfully look at 2 points that we can join. That's going to give us a line that is the set of locus which is equidistant from A and B. Is going to be the perpendicular bisector of line AB. So in the same way, we can just do the same to point BC, because we are also going to find the locus of points equidistant from line B and C. So that means we are looking for the perpendicular bisector of the line BC. So I'm just using the same arc because I think it will be appropriate. So I'm marking off from C, and then both at the top and at the bottom, and I will use the same radius and go to point B now, and go to point B and also mark off to cross the other arc that I just constructed, and this is exactly what is expected of us. All right, so having done that, I just need to bring in my ruler to join these two lines. Okay, so this is going to be my line L1 and L2. So I just need to join them with a ruler. So this is line L2. I'm using green for that. Okay, and then I can also go and join the other set of arcs that was gotten initially. So I need to make them a very straight line. Okay, I think that is okay, and then I'll just join these two lines also, and I think that is interesting. That is good. Okay, I'm bringing my label into this diagram. Now look at this. This is the line L1. That is the locus of point that is equidistant from A and B. It is the perpendicular bisector of the line AB. So if you take any point, maybe here, the distance from here to A and distance from here to B is going to be the same thing. Okay, so that is the perpendicular bisector of the line AB. And here we have the perpendicular bisector of the line BC, that's L2. So this is L2, the perpendicular bisector of the line BC. And then this is looking very interesting. Finally, we are told that N is the point of intersection of the two loci. So this is point N here. N here is the intersection of the two loci that we have constructed on the triangle. And finally, what we are now asked to do is that using N as a center, so we are to use N here as a center, we are to construct a circle that should pass through A, B, and C. Now, that statement is telling us that N is the center of the circle, and the distance from N to C, which is also going to be the distance from N to B, and also going to be the distance from N to A, is going to be the radius of the circle. So I can just verify that it's going to pass through point C, point B, and point A, and I think looking at this, I'm okay with that. So I can just construct the requested circle. Alright, and you can see this is quite interesting as the circle that we're asked to construct. And just like that, we've been able to answer this question holistically as we are requested to do, and that is the beauty of knowing what you are requested to construct. And you can see from this particular question, we've been able to look at first how to get our point of reference, which in this case we identified as point B, because that's the point at which we are going to take our angle as 120 degrees, and then we mark off the arc that is corresponding to 7.5 centimeters along the line in which 120 is inclined. Then we use our ruler to construct the line AB, and then from A we now mark off from the protractor on the ruler, we mark off 13.5 centimeters and put the needle point on A, and then we mark off the arc of 13.5 centimeters on the line coming from B to get our C. And after constructing the triangle in that way, we went to find the perpendicular bisector of the line AB, which is defining the set of locus of points that is equidistant from A and B. And we did the same thing for the line BC. We constructed the perpendicular bisector to define the set of locus that is equidistant from B and C. And finally, we are able to use the point of intersection of the two loci, that is point N, as the center, and use the length to any of the side of the triangle to construct the circle that we are requested to draw. And with this, we've been able to complete our solution to the question on construction from the Waec 2020 mathematics theory paper, question number 13A. So if you want more videos on construction, just check our playlist. There are quite a few videos that are there that will also help you to build your proficiency in solving questions on construction in mathematics.